Ah, qué raro.
Parece que tienes que iniciar la transmisión, ¿no? No sé.
Qué raro.
Dice, es posible que el enlace que seguiste haya caducado o que la página solo sea visible para un público en el cual no perteneces.
Ah, espera, ¿y este? No, este yo creo. Ahora sí.
Es así.
Ya.
Estupendo.
Una última cosa. Gloria,
Sí,
¿estás?
sí. Estoy en el canal de inglés.
Estoy en el canal de inglés.
Ah, ya, perfecto. ¿Me escuchan por el canal de español a mí?
Escucho por ambos canales.
Ya.
Yo simplemente tengo que optar por la opción inglés porque probablemente va a empezar en español, entonces yo voy a ir cambiando.
Claro. A ver, espera, es que tengo un problema pequeño. Un pequeño problema técnico. Andrés, una pregunta. ¿Tú estás en el canal de español o inglés?
En el español, ¿por qué?
Ah, ya.
Yo me tengo que poner en el
Ah,
otro.
ya, está todo bien, dale. Ya, vamos a partir entonces. Diego.
Okay, so we're going to begin. Diego,
Vamos a empezar con la
we're going to
transmisión.
start with the broadcasting.
Casi todos los
We have
inscritos.
pretty much everyone enrolled,
Dándolo en la medida que vayan
and we will
llegando.
accept them as they arrive. So
Bueno, bienvenidos
welcome to the
al webinar de Robotuk.
webinar for
Voy a
Robotuk.
empezar
I'll
a-
begin recording.
Ya.
There we
Bienvenidos
go.
al webinar
So welcome
de
to the
Robotuk.
Robotuk webinar.
Este webinar se llama
This
Cómo hacer
webinar
tu
is
propio
appointed
robot
how to build your own
y
robot
cómo
and
gestionar
to compete with it. We want to teach
por
you
qué es importante
why it's
para
important
nosotros
for us
esto y por qué
this and
lo
why
van a pasar muy bien
you're going to have so
aprendiendo
much fun
con nosotros.
learning all of these topics.
Así que una cosa antes,
One thing before
para los que no
we
llegaron
begin, for those who
inicio,
haven't arrived in the moment when I explain this, you can put on your English broadcasting channel for those who speak English and Spanish language. So when we have the people from our international guests who speak English, they can actually understand because we're having simultaneous translation, okay? So yeah, let's begin. One more thing to add, in the Zoom webinar format, you can ask all questions you wish. It's already available, so after the presentation, we're going to have a Q&A session, and then you can raise your hand. But for now, you can ask all questions you want on the chat.
Ya, bueno, cómo construir
Okay.
tu robot y
So
competir.
how to build your own robot and to compete with it. Go ahead, Diego.
Antes que nada, les quiero hacer
First of all, I want to ask a question.
¿qué es un robot?
What is a robot? Because first of all, this is something that is not very clear. Well, as an introduction, obviously, something that we all need to know is that integration and communication from different areas is what has built and generated what we know today as robotics. We'll have a basic notion of what robotics is, but I wanted to ask if you understand, do you know how to differentiate a robot from what is not? Diego, for instance, do you know? Well, there's very little awareness or agreement, better yet, according to the definition of what a robot is or not. Now, we may ask ourselves, is this a robot? And for practical terms, for this webinar, we'll say no. And why not? This is not a robot because it doesn't think. So it doesn't make decisions. The fact that it has remote control says that I will provide indications to this artifact. So it won't be able to solve problems or generate something on its own. Different to this, which would be the typical robot that it's a vacuum cleaner. That for this webinar, we will say it's a robot because you put it on and begins doing its job and can make decisions, for instance, turning, not continue to go on a specific direction because there are obstacles, or maybe some other are really smart and they'll be able to perhaps map the place and will be able to decide their own routes. So we'll say that a robot is a mechanism, an artifact that can make their own decisions. Oh, I get it. So a robot, it's not the shape, but or for us, it's autonomy. And in this way, things or autonomous machines would be more robotic. Well, once we understand this, we need to understand why it's important robotics. Beyond the fourth industrial revolution that says that machines are the ones thinking in the end, and it's going to be even more important than the other three revolutions. I want to look at it from this point of view. In a culture from the 1500s, 1600s, there was a lot of people that were didn't have participate. So in a world where it's United States is more and more common and everything is digitalized, the people that don't understand basic concepts will be left aside. That's why it's not only fun, but something that is actually really important and very much interesting to achieve. Apart, also, how can we make robotics to get to people? We've asked this question and we wanted to know, how do you learn? Where do you learn robotics? At college, at work, by doing research? And the truth is that we got to the conclusion that the best way of learning robotics is by doing. Why? Because we're not interested in achieving, having one or two people managing knowledge, doing research in their lab and not learning anything. We actually want to achieve for most people to be able to create and use robotics, even if it's at a basic level, because in this way, in a natural way, due to an issue of the pyramid, right? The social pyramid, we'll be able to achieve more developers. We will achieve a universe of people that will understand each other in a much better way. And we believe that's the real way to get to the development of this. Plus, teaching is not just conveying learning, but also having experiences and living and keeping the experience, because through this, you can actually obtain the real knowledge. And so, since we know that robotics competitions are a great way of learning this, I wanted to ask Diego, do you know what type of robotics competition exists nowadays? Actually, I don't know. Well, still, the concept of robotics competition, even though it sounds so weird in Chile, it's actually a whole issue that we can see globally. There's a bunch of types of formats, categories, levels of difficulties. For instance, in the picture, we can see humanoid robots. They're probably, I don't know, there are different types of competitions. Some fight, some play ball, robots solving different types of labyrinths and mazes, and some others do circuits in a very little amount of time. So there are many differences, many different types. Well, there are many others also. There are some free formats that gives you a specific problem at a specific time. And this great variety gives you this richness, right? This knowledge that is a practical knowledge, much more practical than just keeping the knowledge you've obtained in college. For instance, here we have a picture that was taken at a competition in Japan. And there's some things we can see. First, the amount of people that attend to this type of event. It's not just a reduced group. Many times it's believed that robotics, it's like in a sphere that it's completely outside of the normal world, but actually a lot of people attend. And it's a common space where you can actually share different ideas, not only solving your own problems and then go home, but you actually share a lot of knowledge. There's a bunch of people from different ages, different types of people, and that's really interesting. Beyond practical knowledge, the idea is to share knowledge. Right. Yeah, and within the categories, a very interesting one is the category of Robotracer. It's an advanced category for line followers. On the left, we have the different types of robots in this category, and as you can see, another interesting thing about this competition is that all robots are very different. Some follow a trend of being light and small, some other are bigger, they are more powerful, they have different types of feeling the line. We will talk about it. And on the right, this is the scenario when they practice in this competition. So, what is Robotuk? Well, Robotuk, as you know, it's a competition, but not just a competition. A robotic meeting organized by students from Universidad Católica. And with this, we want to generate a collaborative environment and a community dedicated to robotics. We're not interested about the winner. We're interested about the community above all. Well, Robotuk is not the only competition that exists. There are many. For instance, international speaking, the pictures we saw were from All Japan Micromouse Contest from Japan, the oldest one in the world. We also have another international one, Robotuk. And within Chile, we also have the one from Santa Maria, the oldest one done in this country, and the Buchas from Universidad de Chile, also done for 2 years now. So we, as students from Universidad Católica, we said, okay, we need to do a competition also. As we said before, we want you to understand, like really to convey the spirit that all of these competitions have. Because here, well, obviously there's a very competitive spirit that happens before the competition, but it's never something like in a bad way where we have secrecy and people don't share things to help others. But actually everybody wants to go in to learn, to participate, to meet people with knowledge. For instance, on the left, we have people competing, we as Lamborghino team in Japan. And here you can see we are with the competitors, talking about the results and with, I mean, getting along. Actually, we were at we have our small group that went there to compete to Valparaiso. And it was a team formed in 2018. And we were there for a whole semester trying to improve our robots and trying different designs. And that's really important because, well, despite that you begin alone, you end up with a team. And with these teams, you go to different competitions, you share, and you have so much fun. I'm not gonna lie, you have fun. Now, regarding Robotuk, who are we? Who's behind this future meeting of robotics? Well, everybody's there. Actually, I'm there. The key thing about this is that we are a group of students. No one here is like the professional. No one here is the expert in the topic. We're just a group of enthusiasts interested in robotics and thought about the idea of generating this space of competition to share knowledge. Now, yeah, sorry, Diego. Yes, and we, due to the pandemics and everything this means, we've worked remotely, generally. But that hasn't been a barrier. It's been a great experience, and since we can't still generate a proper date, we wanted to do this webinar to explain and to help all the possible participants. All people, we will help you to build your robot. We will help you in everything you don't understand, everything you wish to learn. And we will also communicate as soon as it's safe on appropriate date for the competition, probably December, January, obviously depending on the status, right? Which is why we will go to what brings us here. What is a line follower? Well, many of you already know, especially those who are more interested, but perhaps some others don't. But generally speaking, a line follower, sorry, it's a robot able to follow a line. But beyond that, it's a specific category for competition. Diego. Oh, sorry. Oh, go ahead. Yeah, so this category, why is this interesting? Well, it's a very simple category, actually. It's not very difficult. It might be your first robot, but at the same time, it's related with a real problem, which are autonomous vehicles. I don't know if you're like me, I've seen news for, I don't know, 5-10 years, autonomous robots are coming and hasn't arrived yet. Just Tesla that have some cars that go on the roads, but some others park alone. But autonomous, not really, because it's a difficult problem, and it's going to be one of the main problems on this year. For instance, a line follower category is a first approach. It doesn't mean that with this you can learn to make an autonomous vehicle from now on, but it provides interesting bases on controls, on steering, programming. So it's a category that is interesting for people to learn, and it's a category that is great to begin. And apart from the line follower, we titled this webinar, How to Make a Robot Racer. So Diego, can you tell people about a robot racer? Well, the generic term, line follower robot racer is this category, this competitive category which we wish to implement. And here we have a video that might explain this in a better way, what a robot is.
Eso es un robot.
That's a robot. A very good one, actually. A racer robot on that category is not achieved in a short amount of time. It's the fruit of a lot of effort, a lot of interactions, and competing a lot because you need to test your robot many times. Now, regarding the good thing about this type of category is that everything is regulated. And one of those things that is very well defined would be the scenario. The scenario that looks kind of like this. This would be like a scale, which we saw in this video. The good thing about this is that having clear rules, actually you can go into the manuals of the competition, or when you enroll in a competition, you get the basis. You're able to replicate actually one of this, and you can practice at home. You can make different types of simulations. You can calculate timings. The good thing about this track is that it has sensors of onset and finish, and a specific aspect that is going to be the milestones, right? These lines here, which are lines that are going to show the robot that there's a change in the curve on the trajectory. In general, at this level of detail, this is the level of details in the regulation on this scenario. So actually, it's very replicable. We've actually done different types of views at the university, and it's really useful to be very well prepared in these competitions, because apart from wanting to learn, you also have the possibility to improve furthermore. So I just want to say that it's very, very well documented. So it's a great opportunity. So begin from now. If you want to compete in this type of category, you can begin from now to build your own tracks. Well, the hardware of the robot, it's the part from outside in the robot, everything that is not code. A robot is separated in three things, basically: sensors, actors, and we will call it the brain. So we will speak about the sensors that robot racers have. A robot racer, the first sensor is the line sensor. The line sensor is, well, to get it, it is a line sensor, but also has the capability to memorize the track where it's riding, and after that, using that memory to optimize the speed when travels again, and achieve higher speed, and to compete, not just in terms of power following a blind path, but also in terms of intelligence, to know how to take a curve, how to drive. And the line sensor, the first one, is the one that allows them to establish where the line is, so it doesn't go to the sides. Usually the sensors use infrared light. It emits an infrared light, and in white, the light bounces, and in black, this is just like visible light. It's absorbed in black. So with the contrast that the line provides, you can determine where the robot is positioned. Obviously, it's not the only type of line sensor that exists, but it's really efficient, and it's the most known one. Another one is milestone sensors, which are useful to know when the curve changes. That white line, we call it milestones, and it notifies when the curve changes. And for that, they usually use sensors along the vehicle. And a sensor that is an additional sensor, it's not necessary for a robot to have this, but it does provide a better category. Now, it's more difficult because it also provides something else. When you have more sensors, it's more difficult to use this information in order to program a robot. But encoders are basically putting an eye on the wheel. What does this make? Well, whether with light, LED light, or laser, or electromagnetism, this encoder is attached to the axis of the wheel, which can be on the back or the front, and it measures the position of the wheel. And the microcontroller communicates it, and depending on the speed, can check the speed of each wheel in a separate way, and also the position and acceleration of the vehicle. So it's a way of measuring. It's like a velocimeter. This is basically the sensors on the robot. This is how the robot feels and senses the world, and this is what a robot needs. So the actors are, if you will, the opposite to sensors. The actors are what the robot uses in order to interact with the world. And the first one are the engines, the most important ones. It doesn't have much more explanation, but they usually use continuous current engine because it's easy to control and it has a really good quality. Also, they use reductions in this engines to change the speed and power. With lower reduction, we send a higher strength to the wheels to a lower speed. So it's kind of like a coupling of the needs. Usually these vehicles are lighter, are very light, they need more power than strength. And the other one, go ahead, Diego. How these robots move? Well, in general, they don't have a steering wheel. They just steer depending on the control of each wheel in a separate way. This is differential traction. And so when you turn a wheel, it goes to the opposite side. This might seem like it wouldn't work so well, but it's a way of controlling that it's actually very, very good. And also, the robot doesn't have so many mobile parts, which obviously makes the robot much more complex. And the other thing is the buzzer. It's a component we can see here. And what it makes is that when you provide electrical current, it emits a sound. And you can also vary frequencies of sound. And with this you change tones. This is useful because it can notify things. It can notify about what the milestones are, what's the mode of the robot, etc. It's like a way for the robot to tell you what's happening in its own program. And finally, but not the least, the brain of the robot. The brain that is actually a more technical language is a microcontroller. The microcontroller of the robot, it's like a computer's processing, but this is much more simple. It doesn't have that much memory. It's in charge of less things and much cheaper. So for a robot, we don't need such a great processor like the one from a computer. And in this case, in the Racer robot, the example we forgot to mention, but it is a Lamborghino, Open Lamborghino, which is an open code robot useful for people to learn to go to the robot racer category. Now this is a highly used processor. It's line and a small size working with the Arduino code, which is very popular. Other important components we found on a racer robot. The driver. What is the driver? Basically, another processor, which is made to transmit strong electricity current. Why? Because the processor can't just provide all the amperes that the engines need to start. But the microcontroller provides instructions to the driver connects directly electrical energy from the battery to engine. This is the only way of providing a good power to the engines. The battery, usually lithium polymer, they have a high rate of download. They can download all the energy in a very low amount of time, not like alkaline batteries we find in toys. They are more safe and more stable, but they don't have this capability. And why do we need these capabilities? Well, robots are usually subject to much higher requirements. And these are dangerous. They can explode, so you need to be careful. They can't even be charged without paying attention because it can be a problem. I don't want to scare you, but a battery has never exploded on my face, but I know it's a possibility. The wheel, also a key part. And it's not an issue that you can leave aside. There are many things we have to say. Not just the diameter of the wheel that indicates will give you more speed, but lower power. I mean, the engine will need more power, but the separation of the wheels, higher separation makes the car more stable, but it's more difficult to turn. And lower separation, the opposite. The wheels can be thicker for more adherence, with a softer material for more adherence, but the thickness makes it difficult to turn, and adherence make them last. They wear much more, and so you need to change the material much more. So there are competitors from the big competitions that use materials that are like $100 the square centimeters, pretty much. But to learn, of course, we don't need that type of material. And finally, the chassis. Where all the components of the robots are. On the left, we see the more typical solution, which is putting the whole chassis in a TCB plate. We will mention about this in a while. And on the right, another option, more advanced option. I think that perhaps this robot is done with a chassis polycarbonate, something like that. So the plate is separated from the chassis. Of course, the risk is that you're adding more material and perhaps it's heavier. The robot will be heavier, which is something that you usually don't want, but all options are available, of course. And the PCB plate on the chassis, it's basically electrical circuits of the robot. The connection, but instead of cables, it is a plate which is made out of copper, and you draw lines made out of copper, and you create connections. All of this done with programs such as LinkedIn, and you can define circuits, solid circuits that will last more and will be much more stable in a much better way with order more than cables. Finally, the connection. It's also a key part of what a robot is. Before building, before designing, you need to know what will connect to each thing. Microcontroller connects to sensors, but you also need to understand that not all these ends, which are these circles from where the lines go out, will be useful. Some are analogous, means that they measure voltage in levels, others are digitals. They only measure if voltage exists or not. So it's necessary to make connection schemes. For instance, the following. In order to know if your microcontroller, the one you'll be using for your robot, has enough ends and the appropriate ones for the whatever task you want to carry out. And finally, a key part of everything that is the construction of the robot are the welding on cables, components, or small components such as FMB. That's something that all robotics developers need to build and learn. Basically, you can link everything. So the good thing about the tin is something that melts at a low temperature and also conducts electrical current. So you need to weld with this type of material. And finally, the design of the robot. It's also important to do this, the design before the construction. These materials are usually not very cheap. An open Lamborghino, thinking about the engine, the batteries, the plates, can be 80,000 Chilean pesos easily. So you can't just go and buy parts. Many times are imported from different countries. And so you need to, and then try. No, you can design this in a CAD software as an inventor, and you can organize, you can download the files of sensors and all of this, which is usually online, and do this everything before building. Now regarding the software, which is going to be well more related to the brain of the robot and how it thinks, one of the most relevant things is the code, where the magic happens, right? When we consider the code, we need to take into account all the actions that our microcontroller will be carrying out, from the most simple instructions, reading a sensor, to calculating speed, calculating this, when finding obstacles. And as Cristian said before, we usually use the Algoritmo platform, the typical. And here we can see the platform, Arduino platform, a language which is useful to learn, very intuitive. It has a background on C. You could program on C, technically speaking, but it's a bit more complicated. It's like going to the next level. And what I wanted to say, especially for this image, is that, well, you always start from a simple thing. When you begin programming, you start with a LED, right? A blink LED, which would be like a LED blinking. And we have the most simple instructions, defining what the LED is, to say that the part that is connected is going to be a voltage exit. And here, look, the most relevant part of the code, what repeats itself, the instruction that the microcontroller will be processing. For the case of the Robotracer, is reading a sensor, determining where I am, knowing what to do with the engines, reading again, and so on. So it's like a loop. One of the most complicated concepts associated to the issue of this type of race robot is the control with the controller. it's usually, you usually use a very basic algorithm. I mean, it's not basic, but the most typical one. It works very well.
Un robot.
Okay, that's a robot. That is actually one that we programmed when we went to Alfaro. It didn't work very well back then, and uses this type of controller, which is PID controller. With there's a lot of theory, a lot of background, and it's one of the most used controllers. And it's based in a functioning principle. Thinking that we have the sensors in the front and the line in the middle, what this does is working according to the error that exists in measuring this. What do I mean by this? The sensor is located on the front side, and we have the line in the middle. When it deviates, I have a difference between sensors. The sensors are here, and the line is here. So here we have an error, right? Measuring error. That error, we try to compensate it, and we say, okay, move with the wheel that is on this side to strengthen the line. The problem with this is that in an ideal world, everything would work in an instant way. But here, since we're speaking about mechanical parts, when trying to compensate for that error, many times you go beyond or don't get there fast enough. And these are the parameters: how fast the reference key arrives, how near the reference is, and how to adjust to those changes on the sense to the reference, and how these parameters are going to be related. What you usually do is, through some mathematical strategies, you try to approximate these parameters to have an onset, a start, and then you just go and change to get to the parameters that allow me having a decent control. As you saw in the previous video, we were just establishing the parameters, and now in this video,
Cuidado, María. Ese robot es el mismo.
actually that robot is the same, but now with the parameters, after testing a lot, after analyzing all the data, and actually this is a robot that doesn't have encoders, so it just works by following the reference. You can add encoders, you can accelerate at some points, so you decide what's the level of complexity, how fine, how you want the control to work. And this is similar, the same competition from the robot we saw at the beginning, and here different to the one we previously saw. Oh, sorry.
Bueno, vamos a adelantar un poco y vamos a notar.
We're going to move forward.
Ahí vamos a ver la diferencia entre la vuelta de...
You see the difference between the trial and now when the robot begins to having this feeling of knowing where it's going.
Qué gran video.
Great video. Well, I want to say that this video from here, that person you saw, it's actually a guest. It's the Ochiai robot who will be joining us in a while and was third place in 2018. A great developer, so you can also ask many questions. and will be here for you to know him. The person here, right? On the right. So, well, now we've finished the presentation, the introduction to what Robotracers are. We'll be speaking with our guests, which are Yuki Nakagawa, the organizer from the Japan's robotic competition, one of the best ones in the world. Kengo, Seiji, Ochiai, great developers from Micromouse
And
from
Robotracer.
and Andrés Bercovich, one of my colleagues. We worked in Lamborghino for many years, and also the creator of the Lamborghini team, and won the competition from Santa Maria 2015, and was kind of a great teacher for me. So we welcome first Andrés Bercovich.
Hola, hola, hola chicos, ¿me escuchan?
Hi guys, can you hear me? Turn on your camera. Just give me a second. Diego? Now let's leave the presentation. We will begin with our guest. Andrés, introduce yourself.
Hola chicos, bueno,
Hi guys, well, my name, you can see me, right?
todavía no, ¿o sí?
Can you?
¿Me ven?
Yes?
Ya. Bueno, me presento. Bueno, soy Andrés
I'll
Bercovich,
introduce myself. I'm Andrés Bercovich.
desarrollador robótico.
I'm a robotic developer for quite some time,
7 años metido en
like 7 years in the world of robotics
o más, ya
or
ya
more.
perdí la cuenta.
I've lost track.
Y me
And
metí,
I got involved
primero de curioso,
first because I was interested.
cuando era más
I
chico.
remember when I was a kid, when I was on the 3rd year of on college, I had a friend back then that was modifying a car, a Fiat 147, and when we got involved in the automatization world through this new platform, Arduino platform, which is very intuitive and very good for people that are not from the specific area of electronics. Many times electronics scares people because electronics, until not so long ago, is not so intuitive as it is now with Arduino. Electronics was really difficult to apply. It's not like mechanics, which is really intuitive. In mechanics, if you have a gear here and another gear here, you know that if it swirls in this direction, the other one swirls the other way around. In electronics, things are not that intuitive. And thanks to this project developed by Italians named Arduino, the knowledge was somehow democratized on electronics, making all the different areas through electronics would get involved to mechatronics world. And among those people, I was involved in 2012, 2013. And we got involved in a competition for the first time, one of the most well-known competition here in Chile, the oldest one so far, which is the one from Santa Maria, the Technical University, Santa Maria, that has as a name, robotics competition, like that. And in 2013, we were making our first line follower. And the truth is that we didn't do that well, but the next year, we got involved on the line follower world, and we got specifically to know how line followers work, the most developed ones. Now we're speaking about the Japanese ones. And I started to watch videos from people from Japan and the All Japan Robotracer Micromouse Contest. With that same level, that same knowledge, acquired knowledge of learning, not only looking at what the Japanese are doing, we participated in 2014 in the robotics competition, and we took over the place. For the first time in this competition, a mechanic would have won. I'm a mechanic as a profession, so it was a milestone for the world of robotics competition here in Chile. But apart from that, in 2014, we realized that there were not many things to do here in Chile because we had won the most difficult competition. So, in an extreme insanity attack, we asked Hewstone, he was just speaking, if he would support me to compete with Japanese. And Hewstone, at another extreme insanity attack, said, okay, let's do it, as if this was an easy task. And so from 2015, so far, we've been developing robot racers, more and more sophisticated robot racers, and an offering to everybody who has supported us in this search of making better robots. We have also published all of our developments, making a parallel robot to the one from our competitions, which is Lamborghino. We made a robot which is open source, and it's easy to manufacture, easy to implement, and it's the Opel Lamborghino, and you can find it in Opel Lamborghino, I'm sorry, Lamborghino.cl, I'm sorry, .com, not .cl, and it's this robot that I'll show you now. Look, thanks to the magic of internet, I have a double camera, and I want to show you the following. This is the last version of Opel Lamborghino, with a bunch of things that are new regarding compared to the previous versions. This is basically a robot racer. It contains everything that Cristian said just now, which is basically microcontroller, also a driver, an engine, but not just an engine, but an engine named Motorgino, which is the last version of our, let me see if I can show you, the last version of our engine, Star Engine, which is this one, and another version, which is an engine we've been developing with the Lamborghini team to transform the line followers from LATAM into robot racers, so we can increase the LATAM level in terms of robotics developers. Everything we've learned in Japan, especially with our friend Seiji. Seiji has been an amazing person, a great friend. He has helped us to understand and to comprehend from a different point of view robotics, not only school level robotics or Arduino, but things that are more developed, such as this, which we're working on now, which is the first micromouse from Lamborghini. With microcontrollers that are more and more sophisticated. We're not working with an RVN 58, but a processor microcontroller which is more sophisticated. It's the STM32, which is usually used by high-level robotics developers, or if they don't, Vanessa's. Actually, Yuki, you will meet her in a while, gave me this book, amazing book, beautiful book that speaks about her version about Micromouse, a Micromouse that is developed to learn about Micromouse. And she uses, in this case, this platform. It's a book. In 2 more minutes, we will listen to her. Yuki, please publish your book in English, because it's extremely necessary for everybody to understand what you know from Micromouse and your whole trajectory. The same con Funada and con Seiji. Please write about the things you do. And I would also like to speak with you now and speak with an audience thanks to the help of internet and translators. We are already near listening. They're ready? Yes? We will receive them now. Okay, so Hewstone, it's your turn, and we'll stop broadcasting here to join the conversation with Yuki. Yes? Go ahead.
Hello, Yuki.
Hello.
Hello. How are you?
Hola Yuki, ¿cómo estás? Ah, muy bien. En Japón, en la mañana.
Can you hear me?
¿Me escuchan?
Sí.
Yes.
Muy bien.
A ver. Espera un poco, Yuki, porque...
Wait a second, Yuki, because I want to, yes.
Hola, Seiji. ¿Cómo estás?
Hello, Seiji.
Hi, how are you?
Hola, ¿cómo están? Muy bien. Con un poco de sueño por la hora en Japón.
Bueno,
¿Escuchan me logran escuchar?
perfecto.
Perfectly
¿quieres
fine.
decir algo
I'd like to
que
say something.
la conexión
FND is also connected,
solamente que no tiene la posibilidad
but it doesn't have the possibility to add camera.
vamos a hacer
But we're gonna go over here.
si no tienes video.
Sorry.
Ahí estamos.
I'll go to those who don't have video.
Ahora lo
Okay.
veo bien.
Now I can see everyone.
Sí, ¿estás ahí?
FND, are you there?
Yes.
Sí,
Hola.
sí, hola.
Can you hear me?
¿Me
Can
escuchan?
you hear me?
¿Me
Sí,
escuchan?
súper bien.
Yes, very good.
Hello? Hello?
Hola, hola.
あ、はい。聞こえてますか？
聞こえますよ。
あ、はい、OK です。
画
OK。
面が映ってないです。
私今カメラないんで。
なるほど。
すいません。
He doesn't
Sorry,
have camera.
Yeah.
Forgive us to not to show his face.
Sorry, my room is so
Disculpen.
messy, so I can't.
Está un poco desordenada mi habitación, no les quiero mostrar.
Sorry.
Disculpen.
Bueno,
It's not a problem. It's not a problem.
entonces, que cada
So,
uno de ustedes,
each one of you, Yuki, Ochiai,
Andrés ya se presentó.
and Funada, Andrés, introduce himself. Could you make a short presentation and we'll be asking some questions. And also, some of the people from the audience, by raising their hands, will be able to make some questions, okay?
Cristian. Cristian,
Can you share the slide?
¿me puedes escuchar? Quisiera compartir en Zoom.
¿Quieres compartir pantalla, Yuki?
You want to share the screen, Yuki?
Haz clic en el chat.
Ah, ya. Ah, ya, perfecto. Sí.
Oh, yes, okay.
Ahora sí.
There we go.
Ahora pues,
Can you do it now?
Okay, okay.
bueno.
Yeah, hello everyone.
Hola a todos.
My name
Entonces,
is
mi nombre es Yuki
and I
Nakagawa
introduce All Japan Micromouse Contest today.
y he estado a cargo de las,
So I'm
las-
Secretary of New Technology Foundation.
de las competiciones, de la fundación. Soy jefe secretaria de NTF y estoy muy orgullosa de dar esta charla aquí.
And I introduce New Technology Foundation.
Es una fundación de nueva tecnología fundada en 1980 con una competición con laberintos. Somos del comité organizador. Podemos ver una foto de Micromouse, de una carrera. Hay una foto de bastante complicado, un laberinto bastante complicado. Y como saben, Micromouse tiene una historia muy larga. La primera vez que Micromouse, bueno, se fundó en Estados Unidos con I2Pre y con un gran mouse. Lo pueden ver en la foto blanco y negro. Y en esa época, la microcomputación era bastante básica. Y podemos ver los sensores aquí. Se pueden ver con unos palos para aguantar el laberinto. Y luego comenzaron a agregar personajes. Casi en el 85 empezaron a ser más grandes, pero ahora tenemos un robot bastante pequeño y podemos ver Micromouse en la mano. Así ha avanzado la tecnología y como saben, Micromouse tiene inteligencia artificial en computación y robots. Así que estamos muy felices de conocer estos robots y hacerlos como ingenieros porque tenemos un concurso una vez al año en Japón, 41 años de historia.
Importance of the contest.
Y creemos que es muy importante la competencia.
We hope to keep it open mind.
Queremos tener una mente abierta porque en la ingeniería queremos comunicar la información. Entonces, nosotros competimos y muchas veces se mantienen secretos, pero nosotros no queremos eso. Utilizamos la información. En Japón, Micromouse y los Robotracers,
They compete with
ellos compiten con el ganador del último año. Así que queremos ser originales, innovadores y poder tener muy buena comunicación. Y Cristian y Andrés también vinieron a Japón y pudimos comunicarnos, fue algo muy bueno.
So we can give a talk in here. So that is because of communication. And also we give technology information each other. And Funada and Ochiai is also give information to them. And what is the job of the Micromouse and the Robotracer people? They also engineer. So you can see that these robots, for example, the Koboter is a small collaborative robot. So this is the Denso, and then the champions are belonging to the Denso, and they develop these robots. And you can see the eyeball here. So this is an pet robot in Sony. And this is also engineer of Micromouse. And then you can see the this blue screen here. And this is a company named Fulldex. The president is a Micromouser. This is an how to say submarine, but an AGV in a deep sea. This is also the application of the robot. And also my company, RT Corporation, we developed such a humanoid robot to collaborate with humans. So such a robot development is based on the Micromouse and then the Robotracer, such a basic robot contest. So they trained by the Micromouse and the Robotracer, and then they are grown up and they apply these technologies to these robots. And also Micromouse is right now we have worldwide developers. So we are in Japan and also Chile. So many robot developers in worldwide. And also we have an All Japan Micromouse Contest. It's a huge contest all over the world. And then you can see that so many people gather to here. And then, so President, your country, so she came to Japan. So you can see the bachelor here. And I am here. Oh, sorry. And then she shared the time to us to watch the Micromouse in Japan. So we are very proud of it. And then we give a Micromouse to her. So she promised us to encourage Micromouse in Chile. And also in Japan, we have an 8 branch in Japan. So 8 branch activated the Micromouse developers. And we have an All Japan Micromouse Contest and the All Japan Student Contest. we have two big contests and then a small contest. Okay, let's see Micromouse. You can see video?
Okay.
Okay.
I can see.
This is the 2019 championship running. So it's very, very fast. So I show it again. This is very small, but not to crash into the wall. Very fast, very smart. And then Robotrace is also amazing. So this is a Robotrace. So this is a Robotrace, and the champion's machine is gets through the very easy. So first round is an check the course. Amazing speed. Yes, this is the champion's running. So Robotrace can landing 3 times. The first time, robot to check the course, and the second time, robot to get through the very first time, and the third time, they aimed on Mach speed. It's so amazing. It's unbelievable why they don't miss a course. So amazing contest last year. So we are very, very happy to see such a contest in Japan. And you can also enjoy the through the internet. And also, we facilitate to develop the Micromouse and the Robotracer. In Japan, we have a kit also. And then Andrés introduced their robot. So please learn with their robots in Chile. So in Japan, we have a textbook such a way, and you can learn almost development. So you can learn how to develop the PCB programming and how to solve the maze. And you can see the basement of the robots. And you learn here. And you must keep originality from this one. Not use the kit, but develop yourself. And also, we also the training tracer. We have a so basic one. And the Lamborghino is a very good Robotrace training kit. And this is for the, how to say, essence is gathered in this robot kit. And the champion Hirai supervised this kit to learn something from this robot kit, how to how to make artwork in the PCB, how to run and organize the robot, and what is the problem, what is the improvement from here to the good robot. So you learn the originality, innovative things, and how to the basic technology of the robot. We keep the originality. So we are happy to introduce our Japanese robot contest in Micromouse and Robotrace. And this year's contest, as you know, worldwide have a very heavy disease of COVID-19. So we give up to have a meetup contest. But we plan to have a contest in online. So first time, student contest in October 4th. So this is online, so you can see through the internet. So please check our site. So now we don't have any URL to introduce right now, but we introduce here almost September, I think. And please join us. Thank you very much. And then I also introduce Ochiai and Funada here. Ah, thank you, Andrés.
Ahí está el libro.
Yeah.
Yeah.
Please
And,
translate your book to the other language, please.
okay.
Yuki, ¿tú hablas, o sea, tú me escuchas ahora bien?
Can you hear me? Can you hear me, Yuki?
¿Me escuchas ahora
Can you hear me now?
la traducción?
Can you hear the translation? Hi, can you hear me, Yuki?
Andrés, can you translate it?
Es que el micrófono, Gloria, tu micrófono
The mic-
está desconectado.
Can you hear me now?
I can hear.
Can you hear
I
me?
can, yes, I can hear.
Seiji me escucha.
Now, how about now? Yuki, can you hear me now?
Yes.
Eh,
Okay, this is his robot. Very
Es un robot muy inteligente.
Okay,
acércalo más, Ochiai. Muéstralo bien a la cámara.
Show to the camera if you can.
yeah, I will send you my Micromouse
Les voy a enviar mi Micromouse
Facebook Messenger. Wait.
en Facebook Messenger. Espérenme.
Okay, I share you.
Ok, lo voy a compartir.
Aquí está.
Here it is.
Aquí está.
A ver, lo están mandando por...
Oh, you're sending.
voy a compartir
Se ve asombroso.
I'm going to share the screen.
Voy a compartir pantalla. A ver.
はい、画面共有
Diego, déjame compartir pantalla.
あ、いや、Facebook に
はい。
写真を送ったはずなんで、確認をして、
それを
多分
Voy a
は
compartir.
ずです。はい。
Okay, okay.
Este es el robot de FND. Una...
This is the S&D robot.
This is my Micromouse
Este es mi Micromouse.
I'm building now. 何話せばいいんだろう。
日本語で言ってくれば通訳しますよ。
いや、なるべくは、まあ、頑張って英語で喋ると思う。So, this is,
Entonces este es el,
this is my new Micromouse.
mi nuevo Micromouse.
But my mouse has a 6-wheel.
Tiene 6
this,
ruedas.
very unique style.
Es un estilo único.
Most people Micromouse is a 2-wheel or 4-wheel. But
Usualmente tienen 2 o 4, pero 6
has more stability and more
se ve
grip.
más
So I think,
rápido, es más rápido. Creo que 6 es mejor para Micromouse. Así que en mi mouse quise construir
Six-wheel.
construirlo con 6 ruedas.
あんまりちょっとうまくいかない。これ今作ってるやつなんですけど。
Okay, he is developing for this robot right now.
What?
消えちゃった。
¿Qué cosa?
Sorry, what?
I introduced his robot. Can you
Me-
go again?
Ah, sí. Disculpa. Yeah.
Sorry, I'm not good at English. This is easy that way to translate by Yuki.
Yeah, this is
Easy.
another
So
robot.
sorry.
Don't worry.
So
Ya,
you can see
perfecto.
this robot
Okay, don't worry.
has 6 wheels, and but motor is one here, one here. So this is all connected with gears. And you can see sensors here, 6 sensors here. And also, どうぞ。
そうですね。このロボットは普通のロボットって壁を見るセンサーが受光と発光で1対1対応じゃないですか。
はい。
それがこのロボットはそうじゃなくて受光のセンサーが2個しかないですっていうところをお伝えいただければ、はい、お願いします。
So this robot has an 6 LED, but an receptor is only 2. So this is also the unique point. So normally, Micromouse has 4 sets of sensors, LED and receptor, and but Funada has 6 LEDs, LEDs, but 2 receptors. So how to get the information of the world? These LEDs illuminate light in ordinary, and get a receptor get a light in an ordinary. In order to the one light and one gate, one light, one gate. So at last, robot get the information of the world and the maze. 他は何かありますか？ここは？
以上です。That's all.
この丸は何ですか？
Gracias.
Well, which? At center of the circle?
So
this is a suction fan. This is suction fan. Top Micromouse top record. なんて言うんだろう。
日本語で
Top player also use a suction fan. This is suction the under the air of the Micromouse and get downforce like formula curve. So get more high grip to when turn the maze.
When the robot have a top speed, and sometimes maze and the robot have the space, and this suction parts get the downforce to get the grip over the maze and these wheels. So top runner has such a suction parts to keep the grip and the speed. So this is a very small one, and then he developed by himself. So we keep the originality like this. Okay, thank you, Funada.
Perfecto. Lo que está explicando aquí la Yuki es como el
So Yuki is explaining how the fan vacuums the air to keep the robot with adherence, and I've seen it. It's one she has shown how she places the hand like that, and the robot is kept in that way. It has an amazing power.
Así que es muy interesante.
So it's really interesting.
Muy bacán el robot de...
It's a really cool robot.
Yuki, ¿qué te parece?
Yuki.
Ochiai,
Well, Yuki, Ochiai,
y Andrés. ¿Qué les parece?
Nana and Andres, what do you think if we answer some questions from the audience? They have many questions. There are many people raising their hands. And so, to those who are raising their hands, please, go ahead.
Thank you. Gracias.
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 Yuki, ¿puedes quedarte para
Yuki,
responder?
could you stay to ask to answer the questions?
Okay, gracias.
Yuki, many people want us many people are asking us what's the name of your book?
Oh,
The
okay.
name of your book, because
This book in
the book is
Japanese
in
title
kanji,
is
and we
let's
can't
start
read.
Micromouse. So let's start with programming and Micromouse.
This is
But what's the name of your book?
in Japanese.
I leave it here.
I ask you
In
because
Japanese,
many people ask me what's the name of your book.
Yes.
Name,
text. Please check a text.
Text.
Okay.
Text.
Amazon shop link at the
En Amazon.
Okay, thank you.
Hay un link.
A ver, ¿alguien tiene alguna otra pregunta
Does
para
anybody have another question?
Yuki, para Ochiai, para
For Yuki or Ochiai, Andrés or anybody?
las pueden escribir por el chat o pueden levantar la
You
mano?
can type them.
It needs to translate. This book.
Your book.
This book needs to translate to Spanish.
Yeah.
Oh yeah. Well, we have many questions.
Sí. Mira, acá va una. Bueno, esa pregunta.
Here there's one. Well, there's another one. I'm going to read it in Spanish for everyone. Which is, what type of engines do you recommend? To use brushless or brush ones? These are normal continuous current and the process without a brush, which means I'm not going to explain it now, but these are engines that use different controllers. It doesn't go directly to current, but has another controller.
Okay, I replied in a text here, and then almost in a quartz motor is used for the Robotrace and the Micromouse. Some very small people use it on brushless, but an almost quartz motor is used. Can you hear me?
Sí, sí.
And engines.
Había una pregunta, Yuki, que te habían hecho.
Question, Yuki, about the engines.
A ver, vamos a hacer que un Salvador Álvarez tiene una pregunta. Lo voy a poner.
Mr. Álvarez maybe has a question. Salvador.
Hola a todos. Hi.
Hi, everyone.
My name is Salvador. I'm from Mexico. And the question is, how long does it take, or how long do you think that, because if this situation of pandemic is going to take to a normality? I'm saying you can be together with another person or a crowd of people. So how long do you think is going to take to a normality? Thanks.
So sometimes the noise is I can't hear all intense, but so in the pandemic, so we communicated with through the internet, like on Zoom and then Discord, and sometimes chatting, and also we communicate in how to say, なんだろうね、through the Facebook, sometimes on Twitter. So in usual, we in Japan, a very wide country, so many people gather in once a year in the contest. But usually we communicate with each other through the internet.
Aquí.
Here we have another question from Marcelo Ortiz. It says, this is the question. Robotracers are very advanced in Japan. Would you consider changing the lane for a non-controlled environment instead of the basic line, perhaps doing something different with, I'm thinking, obstacles that are not controlled, perhaps simulating people, and robot racers could crash those people.
Andres, please translate it.
Ah, no se te está traduciendo. A ver. A ver. Espera un poco. Gloria, te voy a activar el audio. A ver. ¿Se puede activar el audio nuevo, no?
Yuki, can you hear me now?
¿Me escuchas? ¿Ahora se te está
Yuki?
traduciendo bien?
Can you hear me now, Yuki? Yuki, can you hear me?
I can't understand the Spanish.
Yuki?
I'm going to tell you in English because we have a little problem, but
Lo voy a decir en inglés. Entonces, los robot racers son muy avanzados en Japón. ¿Consideraría tal vez cambiar el escenario a uno no controlado, tal vez con algo que simule la vida real, autos autónomos?
You mean that Robotrace apply to the real
O
world?
sea,
¿Qué cosa? Disculpa.
So is he or she mean Robotrace apply to the real world, not the
robot racer aplicado al mundo real.
Claro, yes.
So application of the Micromouse and the
La
Robotracer.
aplicación de Micromouse y Robotracer en el mundo real es Ochiai. Y se pueden ver,
Okay, I show you.
le voy a mostrar.
Habilítale el compartir pantalla, Hewstone.
Sí, sí puede. ¿Puedes compartir Can you... A ver.
Can you see here?
Sí, sí.
Pueden ver aquí.
So this is a super challenge. And then also this is a big robot in the real world.
Es un gran robot en el mundo real.
So this is not a Micromouse contest.
No es un concurso de Micromouse.
And they apply to the real world.
Se aplica al mundo real.
This robot moves
Y estos robots
like
interactúan
car.
como autos.
So you can check the
Y pueden revisar Scuba Challenge y sus videos.
Perfecto. Entonces,
Yeah.
eso es más una competencia.
Perfect. So it's more like a real autonomous competition, real autonomous car competition, like in a scenario that's on a daily basis with pedestrians and all of that. That's great. Didn't know about it.
I have a question to
Marcelo Ruiz is saying thank you for that.
Seiji,
Which
¿qué
microcontroller are you using?
microcontrolador usa
Robotracer.
en Robotracer?
I use the
Uso el...
Lo
voy a mostrar.
The
como microcontrolador.
the RX series.
RX3. RX3.
Okay, I can hear you. Okay.
Ahí puedo escuchar.
So, my turn.
¿Mi turno?
I'm using
Yo uso
micro.
ST micro, ST micro, M3. STM32 es mi controlador favorito.
And why you're not using STM32?
Yes, SM32.
SMT32, sí.
The SM32 is very
Muy
powerful and
poderoso
useful.
y útil.
So I recommend to use this.
Recomiendo usar eso.
Hay una...
There's like, there's another person raising their hand. Carlos Cruz, I'm gonna give you permits to speak.
Hi everyone, my name is Carlos Cruz. Yeah,
Hola a todos, soy Carlos Cruz, soy de Chile,
Católica University.
de la Universidad Católica.
I am, well, first of all,
Primero que todo,
it's an honor to be able to talk to you guys. So,
es muy agradable poder hablar con ustedes.
I wanted to ask
Y
about
quería preguntar sobre
the program behind the robot in that sense.
el
I was
programa detrás del robot, de alguna manera.
thinking that there has to be
Estaba pensando que
there have to be so many variables to
hay tantas
take into
variables
account when
que hay que considerar
programming the robot to move.
al
Do
programar un
you
robot para
use
que se
any
mueva.
kind of,
¿Utilizan algún
physics
tipo
simulation
de
inside
simulación de
the
física
the
dentro
robot
del robot?
that
En el
it can
sentido en que
control how it will
pueda controlar
react against acceleration,
cómo reacciona con respecto a
how will
aceleración,
it take turns if
o que también va a girar
the robot is going at a certain speed.
a cierta velocidad.
I wanted to ask about
Quería preguntar sobre
program that controls everything,
el programa que lo
what are
controla
its main aspects in the sense,
y cuáles son los aspectos principales.
if it is capable of I
Si
don't
es
know,
capaz
predicting or
de
controlling
predecir
yeah,
o controlar cómo reacciona un robot con respecto a distintas velocidades.
I don't know, that's the part that puzzles me the most, and I find it
Eso es lo que
very interesting.
más me da curiosidad y creo que es muy interesante.
So, well, no.
Okay.
¿Ok?
I have the last one to Funada.
Oh,
Tengo una para Funada.
Funada, mejor lo digo en español.
Maybe
¿Cuándo
in Spanish.
vas
When,
perdón, voy a cambiar de idioma aquí.
sorry, I'm going to switch video. Funada,
Yes.
when are you going to transform your classic micromouse into a half-size micromouse?
Ah, okay, okay.
Ok. Yo ya hice uno de tamaño medio. Les voy a mostrar una foto.
Okay.
Ok.
Wait.
Un momento.
I'm finding my.
Déjenme ver si puedo encontrar la carpeta.
Well.
But his robot is so small.
Yeah, it's so
I see. Yeah, my love is so small too. Difficult to find out.
Difícil encontrar.
Yeah, his robot is very small, and then his mouse is mouse.
Su mouse es pequeño.
This is this one.
Es este.
Good picture.
Comparta pantalla.
If you could share the screen, if you could share the screen.
Please share this picture.
Ok.
Por favor, comparte esa foto, Houston.
Ya. Voy a compartir pantalla ya. Esperemos un segundo.
Just hold on a second.
Es muy pequeño.
Al tiro, al tiro.
Can you share this side?
Can you?
¿Puedes decir cuál es el tamaño?
Okay, waiting.
Do you see? ¿Ven? ¿Bien?
Okay. I see. This is my first.
Este es mi primer Micromouse. Lotus.
Lotus, yes.
Lotus, sí.
This is purple PCB. It's so cool.
De PCB.
I like it.
Muy frío. Me encanta.
But this is
Pero este es
my first.
mi primer
But I'm not
Micromouse.
quit the classic size.
No he dejado el tamaño clásico, pero quería hacer un tamaño y completar un tamaño más pequeño.
Okay, fat side.
Tamaño mediano. Mitad de tamaño.
船田さん、サイズ教えてください。
At this side. At this side. Okay. I measure.
maybe
Tal vez
this
este
only
es el único
60 centimeters.
60 centímetros.
Centimeter.
6 centímetros.
60.
60 milímetros.
Okay, yeah, 60 millimeter. Very small.
Muy pequeño.
And weight.
¿Y peso?
Weight is maybe
Puede ser
10,
10,
no, 50.
50 grams.
50 gramos.
No,
50 gramos.
12, maybe 12 grams.
Tal vez, no, 15. 12 gramos. 12 gramos.
Oh,
12,
okay.
maybe 12 grams.
12 gramos.
Very small.
Muy pequeño. Con
With battery, maybe.
Okay.
batería, tal vez.
60 millimeters and then
16 milímetros y peso 12 gramos. Muy pequeño.
Very,
Muy pequeño, muy... Sí.
very small.
Okay, thank you.
Ok, gracias.
Thank you.
Gracias.
So,
Entonces,
Ochiai and Funada are very
Ochiai
good developers.
es un muy buen desarrollador.
To him later. Thank you very much. Gracias.
Muchísimas gracias.
Gracias.
Thank you very much, Yuki.
Muchísimas gracias, Yuki.
Best regard to you.
Please join and develop the robot.
Ochiai.
Muchas gracias por desarrollar los robots.
See you the next year.
Nos vemos el próximo año. Sí,
Yeah.
gracias.
Yes,
Y los veo.
obvio. We will invite you to Robotuk also.
Thank you very much.
I hope.
Bye bye.
Muchísimas gracias.
Bye.
Thank you. Gracias.
Muchas gracias.
Bueno,
Hay chicos preguntando cosas.
sí,
Me gustaría responderle a Carlos.
sí, se perdió la pregunta ahí un poquito. Vamos a
¿Puedes habilitarle el
activar.
micrófono a Carlos para que
Sí,
nos
sí, Carlos. Que los japoneses tenían poco tiempo para estar, pero nosotros podemos contestar ahora el resto de las dudas, así que no se preocupen. Otro día podemos hacer otro webinar con ellos. A ver, Carlos, creo que ahí te voy a activar el audio, ¿no?
¿Aló?
¿Puedes hablar, Carlos? Ya, sí.
Sí, ahora sí. Sí,
Ya.
lo siento, sí. Me puso un poco
Carlos, can you speak? Sorry,
Supongo que no me
I was a bit nervous.
no logré hacer mi tontería. Pero, o sea, no, mi pregunta
So
iba
my
dirigida
question was
hacia el programa que
directed
corre
to
el robot
the
y, o
program
sea, cómo,
that they use with the robot.
o sea, que asumo que una de las partes como más
I imagine that one of the most important things are the issue of the system
de control del, o sea, de control del robot en este caso y de cómo,
to control the robot
de cómo
and
reacciona
how
frente
it
a
reacts
su posición y
when it changes the position or
o sea, básicamente
so basically
el tema de la reacción y movimiento,
reaction and movement. If there's something done physically or if the robot can simulate and check the acceleration that needs to keep or the movement to keep track and not losing, not turning, right? So is there a physical simulation system within the robot? The physical simulation system wouldn't be in the robot, but better yet, it's something that you program at another program, computer simulation program, because within the robot, the microcontroller usually doesn't have enough capability, and the simulation requires a lot of capability. But yeah, it's simulations are carried out. Personally, I'm not, for the robots I've built, I've never done simulations generating the physical body of the robot, because in general, it's not necessary. You can test it with the robot. And to specify some things, you have mathematical models. To start within PID control, there's a whole theory, mathematical theory, on how to get the perfect constant required for the control. But actually, this issue of competing is testing and trying. And yeah, a physical simulation, I think, might be more necessary for a robot that doesn't fail, not so much for a competition that goes to the highest level. I don't know, perhaps for doctors, not like you're trying to compete, but trying to make a task in a very accurate way. Now, Carlos, if you want like the secrecy for the robot to have the same control, I mean, you have the Seiji shot or the Hirai. There are some secrets. For instance, perhaps, well, the idea of the racer robot is that having the maximum speed always respecting, not surpassing the maximum or limit acceleration. Because what you get from the race, that's a strength, and the mass is constant, but acceleration is the one that has to be kept under control. So what you do is simulating, I don't know if simulating, but adapting the movement of the robot. So having the maximum acceleration, the possible maximum acceleration without derailing. That is something that I've learned in college from, I can talk about the formula or the technique in order to keep that acceleration. So if you go through I don't know, a curve with 1 meter diameter, so you know that the speed at a square is equal to the ratio, equal to acceleration, it's equal to acceleration. So if you know the maximum acceleration and know the radio, you know the maximum speed to which you can drive. Right. On the other side, if you have a straight line, you know that following the same way, there's an acceleration which is related and an acceleration which is centripetal, and those must be controlled. I'll publish very soon that study. It's in Spanish, and I think it's the first document done about Robotracer in a language that is not Chinese or Japanese. So I'll publish on the Lamborghino website and also on the Robotracer Micromouse. But it's a huge code. That's the cool thing about that all of these developers have. They are not even programming a robot to drive at specific speed, but will always drive at the maximum possible speed, even more, since they are at a limit of their acceleration. Because from what I know, Funada Kengo has a robot that manages accelerations above 18 meters divided by square centimeter. That's a lot. On the track, that's way too fast. So in order to counteract that acceleration, you need to use wheels with a lot of that can actually, that are very steady. In 2017, this happened. In 2017, we went to All Japan Micromouse Contest, and there was a competitor named Yakuni. And I've never seen it. I think it was a great developer. The thing is that Takumi had a robot made with wheels with nanotechnology material. And that material was like $100, a sheet of paper, and was done by, I don't remember the company, Hitachi did that. I don't know, for those who travel by plane and see some trays, actually, I'll show you. Well, you know this type of wheels, the wheels that are sold in Colombia or Mexico, from a material named resin, I don't know, something like rubber resin, and it's like they have a great adherence. rubber gum. Here you can use it on the wheel. So it's actually when I try to move it, you can't. Now, the material that Takumi was using was 10 times more than that.
No,
It's aerospace type of material. I mean, the acceleration you can achieve with this is easy. I don't know. Like, I mean, you could. Well, it depends on the weight of the robot. With Takumi, I've learned many things. One of them is that weight is important, but more important than weight is how it can, the attachment. Actually, Takumi's robot uses batteries that are AA. And you think, wow, and we grab our heads and thinking, a robot that weighs 400 grams and it goes so fast. And it was because of the material done with Hitachi. So this grabbing systems always improve. Being asked, Anderson Moreira, where can I find these wheels? This, I asked them to a Colombian friend. They sell them TD Robotica. By the way, we also have all the components we mentioned before to build an Opel Lamborghini robot. We have a list. You can get it in many stores. I mean, what stores you can get it? We also have a list to whoever wants it. It's great for those who, when you want to learn about robotics and are troubled about where to buy the parts and knowing if it's the appropriate part, because it's difficult. Here in Chile, we don't have that many specialized stores. I mean, we have them, but you need to know what to find. And we don't want this to be an entry barrier for those who want to build a robot. Actually, about that topic, which is a great topic that Cristian mentions. Well, first I want to answer a question from Juan Perez. Juan Perez is asking, I'm new in this type of competition and like to ask if there's a way of recording the track on the competition with encoders. I appreciate advice. Well, it depends on what processor you're using. For instance, if you're using Arduino, Arduino doesn't have a lot of memory or RAM or processing capability. So using, technically, encoders, it's not such a good idea because when you make an interruption with the Arduino, well, you only have 2 interruption cables, and they're very inefficient because yes, they're fast, but they interrupt the whole routine. So if you have, for instance, a wheel with many rounds, per revolution, if you're using a Fat Hammer S371 engine, like 500 pulses per revolution on the axis, and that's a lot. It means that every time the engine that drives at 1000 RPM, every time for each RPM, you're having 512 pulses. So the processor will melt. There's no way of processing so much information. But what you use in this case is a solution that Funada Kengo taught me, which is using something which is Motorgino, well, you can't see it very well, but the engine is based on this. And instead of communicating with interruption, communicates with SPI, the SPI protocol, which is much faster, much more efficient, and you can work perfectly fine with communications on 1 megabyte, 4 megabytes, which is more than enough because you need to understand that in order to have a good reading on the track, you need to make a measurement for at least once every 1000 milliseconds. Understanding that the speed of the Robotracer is going to be between 0 and 7 meters per second. Yeah, and what the SPI makes is it removes the weight of the measurement to the main processor to be in charge of the main program. So the readings I'll deliver whenever the program wants, and all readings being done don't have interruptions. Yes, and adding to what Hewstone said before is regarding the parts, what to purchase. I recommend from now, because you need to understand, if you buy Fallhaber PCR 1331, which is one of the most used one, most expensive ones, it's really expensive. It's an engine of this size, space use. But if you buy this delicate engine, because it's really delicate, if you buy this done in China, it's going to ruin the engine. It's going to ruin the engine. So you need to buy engines that have the necessary adjustment to put it on that axis. And I'm gonna publish that site so you can order in your homes. It's a Polish company. It's Polish. Has the best gears in the world. You can customize them. They're a bit expensive, but if you're buying an expensive engine, I also recommend buying an expensive gear. Yeah. KK, PMO.
Ahí les linké la página de los engranajes.
I've linked the website for the gears. Juan Rosadio. Don't put funny names. Please don't do that. What CI have you used to convert the encoder's signals to an SPI protocol? Funada Kengo recommended it. The MA700, which is really easy to find in China. Actually, no, it's easier to find MI730 in China, which are very good. They're very easy to implement. You only need to read it. This measure, it doesn't measure in the same way that encoders do, but they are angle sensors, so they have faster response times. But at the same time, you need to convert the sign in order to transform that angle position into a real distance. Actually, one of the things that happened with the Motorgino, it has like 200 accounts per millimeter, which is too much. So Arduino gets stubborn when working at such high speeds. So when the engine has such high revolution, we need to decrease the sample rate to 0.5, I'm sorry, two readings per millisecond. So 500 micrometers, which is a lot. It's a lot for Arduino. Not the case for those using SMD32 or even Team in the area of Arduino. It's nothing for remittances in terms of what Seiji Chai's duty or Funada. And then so we don't have a lot of time. We'll try to answer the questions remaining, most of the questions, and then we can continue in another webinar as Robotuk. We'll try to answer most doubts now, and then I'm sorry, but we're going to have to say goodbye. So Marcelo Ortiz was asking about what's the engine that Robotracer uses. For habit, SR 1331-006. So SR states the type of it uses diamond. 1371, 13 millimeters diameter and 31 length, and 006, 6 back. So it's an expensive engine. I don't recommend it unless you have a level. This is an engine which is not recommendable. The one we had, Andrés, I broke that. 2 or 3 broke down. It's delicate. Oh, we weren't very lucky. if you are a mechanic of clocks, buy that. If not, buy Maxim DX10, which is basically the same line of device. Oh, and that is something that I've learned with Funada Kengo. If you're buying Maxim DX10, which is the typical that many Mexicans use, and hello to Mexico, by the way. If you use that engine, I recommend not buying the 6 volts, but 4.5 volts, because it's 1 unit. And there's one question. Andrés, I want to answer a question to Mateo Tomás, because the translation at 9, and it's in English, so this is for you. Your question is, I lost it, sorry. Once again, your question is, Mateo Tomás, yes. You began storing the pulses of the encoders according to the milestones of the left, right? Storing the amount of milestones, the amount of pulses per milestone for distance. And you're asking if that's the best way of doing so. I think that, yeah, maybe you speak, this is the best way of safeguarding the distance between, of each curve. And the answer is, not necessarily, but it's not bad. It's something we've used a lot. Now, the most tidy thing for a mathematical model, perhaps, to calculate whatever variables you might need in a right way, is millimeters, centimeters, or a real measurement. Since if you need to change the wheels to the robot, you can change different parameters, and which are not related to the real distance that could change, or perhaps changing an encoder with a higher resolution, and you wouldn't have to change the whole program to use it. For distances, it's the best. Now, what other developers doing, such as the Japanese, is that only distances in terms of curves, which is calculated by the difference between the distances that have been traveled per wheel, and in general, not just the curves and distance with encoders, but also accelerometer and gyroscopy, to include them in a function, if you will, and with that to determine the real path where it's traveling. And when there are curves which are very short, like this, a robot, a line follower would deviate it a little bit or make it lose speed. Those robots go like this because they know that going in that direction without changing anything wouldn't leave the line. So they have this ways of recognizing the small curves, which are somehow to lose track, and they can avoid this, and you can have a better grasping it. But that's a very high level. Even I think you need to use things that go beyond PID control, like estimators or some filters that make a difference between the real status of the robot, and not just the error of the state you wish to have, which is the status of being in the center of the line. Hopefully that answered your question. Cristian, if you could answer the question done about how to participate in Japan's contest, if you know about the requirements. Yeah, we participated in Japan's contest. Well, it depends on the tournament. For All Japan Micromouse Contest, you need to go on the website. It's in Japanese. You need to translate it. They have an English version still. And the way of competing is that you need to send your robot's features. For instance, what type of processor. If you're from Japan, you need to participate in other championships and having points, and that is the only way of classifying. But if you're international, in order to, well, knowing that someone coming from a different country to Japan, it's not an easy thing, and not too much people enroll. So you need to describe how your robot works, the parts and pieces, also algorithms. There's a description of the robot, and based on that, you're selected if you have the appropriate robot to participate. If it hasn't changed so far. Well, now with the online version that Yuki mentioned, due to COVID, I don't know what the rules are going to be. Yeah, and before All Japan was open for anybody who could travel abroad, as Hewstone said, but now since we are in this rule standardization process, Japanese, actually Chileans and Japanese, actually Latin American with Japanese are the idea is for everybody going to All Japan Robotracer Contest or All Japan Micromouse Contest have a minimum level. And that minimum level, in the case of Japan, needs to win at least 1 point within a local competition. For now, Japan is the one that is receiving foreigns, but once we begin with the scoring standardization to go to All Japan, probably you're going to have to achieve at least 1 point in Latin American competitions. In that way, it's like the Global Cup, this contest race. Now, to answer the last question, and the next questions are going to be answered on Instagram, okay? Or Facebook. We have Robotuk media. As I said, we want to help you to be ready for this competition. We understand there's a lot of people that, well, actually using the pandemics, it's not a bad thing to dedicate the time we're not using in going out into learning new things. So beyond this webinar, we will answer doubts on the website because we wish to have the most amount of participants as possible and for everybody to go and to participate. So don't worry. Now, due to time constraints, we need to answer the last question and then we say goodbye. So the last question is selected by our team. According to your criteria, what's the engineering area where I can develop in the best way for the robotics of the future? Electric engineering or computing? Andrés, this is a question that you can answer just like that without right or wrong answer. Where am I? How am I sniffing the future? What do I think? I think that robotics is to summarize, because it's a really open question. When speaking with a robotics expert, it's like speaking about an expert on humans. Who is an expert on robotics for humans? It might be a teacher, a doctor, a musician, anybody, anyone. That's why we're speaking about robotics. Any area of robotics might be an expert on robotics. Everybody is an expert, or no one is an expert. So the question is, what's the path, the line, the projection, the future of robotics?
I think
that the industrial issue is somehow clear. We're actually late to the industrial world. We have Japan, the US, China, Taiwan, Singapore, and that's it. Russia doesn't exist, and Europe doesn't exist, and nothing exists. Latin America doesn't exist without industrial robotics. But there's a new area in which technology is gonna be extremely necessary, especially thinking about pandemics seasons. For instance, robotics applied to things that people needed to do before. For instance, a concert. In the past, a concert needed to have a camera crew, sound technicians, music. For a while. So I think that my sense is that the robotics world, or something we take advantage to, is robotics applied to automatizing events production. For instance, a YouTube study that is completely automatized, a TV set that is completely automatized, a concert that is completely automatized. You no longer need to have 50 professionals to get us to have a stage. And you need to understand that the public, the audience, it's gonna be less. Very interesting. Robert says that 30 people will be participating in a specific area. So you don't get infected with COVID, to decrease, or it's a decreased risk or a lower risk. So you can have more people on top of the stage. You need to decrease the amount of people. And for that, you need to do this with robotics, because you can decrease the level of production, because in the world of music, we're used to looking at Lady Gaga at the Super Bowl, where you have a huge show with 500 people, and suddenly you have someone with a guitar and some lights. That is not great for anyone. So to get to a level that has the same level of production but with less people, robotics is necessary. I think that's the thing. And don't worry, electric engineering, computing engineering, still, if you go to robotics, you're gonna have to learn everything. It doesn't matter the area. Me and Andres are mechanics, and we have to learn electronics, computing, a lot. So I would decide based on what I like. Computing perhaps gives you, maybe you'll be working more in things related to code, image processing. You study that more due to like computing engineering more than electrical. But electrical, apart from knowing about the circuits, which is like the main basis of robots in a more elemental way, they can do things that are related to robotics. For instance, smart energy generation systems. Perhaps it's more useful, or it's easier if you start on the electrical side. Now, in reality, all of those differences being made are not going to be very useful. And I recommend, I don't know, check the subjects you like them more, or the area. But with robotics, you're going to have to learn everything. And by doing, you're going to realize that you're going to realize what you actually like more. But checking connections, perhaps doing schemes, or programming by itself, what code is more efficient or prettier, or the mechanical side, okay, what wheels, all of that side, that is more mechanical, more, that's my recommendation. I just want to add, Seiji Ochiai is IT, Funada Kengo, computer science, it's not even electronics, but computing. And the winner, the historical winner for Robotracer, Hirai, Niki Hirai, has won 8 or 9 times this championship, also mechanic. So it's great to study electronics, but it's not gonna make you a champion on anything. These champions usually are great engineers working in different things, not all, but many of them. And this is like a hobby. For the same reason, they apply everything they know, and they apply it in the the industry to this hobby, so it's really difficult to win, but it's really fun to share with them. Great. So Diego, that's it. That's it. So thanks everyone for joining us. I don't know if we can make a general buy and check everyone's cameras now. Seminar version. We'll do it for next time. Hopefully you liked it. Yes, thank you so much, everyone participating. Whatever questions were not answered, please put them on Instagram. We have a team. People are going to be answering. So thank you so much. And hopefully we will have another moment such as this to continue to go deeper in the subject. And pay attention to the media, because as soon as we have more certainty, whether we do it with specific protocol for COVID or I don't know how, we will publish the dates on when the competition will happen. Even if it, I don't know when, but will happen. So that's it. Thank you so much, everyone. In 2024, that's it. Take care and don't leave your home. Thank you, Andrés. Thanks, everyone.
Veamos que quede bien grabado, eso sí. Sí, ya paré la grabación.